I am Anil Kumar. Welcome to my series on Radian measurements. Till now, we have seen what is the relation between the angles measured in degrees and radians. We also now understand how to find an angle in radian and how to draw when we are given angles in radians. In this video, we'll explore further the relation between arc length, radius, and angles, the subtended angles. After understanding these concepts, we'll have 10 multiple choice questions to ensure that we have learned these concepts and we can easily apply them. And then we'll move on to the next topic of understanding angular velocity and the linear velocity. All what you need to know for this particular video is right before you. So we're trying to figure out the relation between arc length, which is the arc AB shown here, a portion of a periphery of a circle, which is enclosed by the radii on two sides, and the subtended angle theta, right? So that is how these things are related, correct? The relation is that this arc length A is equal to product of theta and r. I could write here A equals to the product of r and theta. Or we could write theta as equal to ratio of arc length to radius. Arc length to radius, or we could write r, the radius, as equal to the ratio of arc length to theta. Now these three formulas can be summarized in the form of this triangle, easy to remember, just as you used to learn velocity, displacement, and time. Perfect. So similar way, they are related. We say that arc length is directly proportional to the subtended angle theta or the radius. So if I increase the radius, in that case the arc length will increase, and if I increase the angle theta, the arc length will increase, right? That is how we get this particular relation. Now we'll explore further the relation between the angle theta, arc length A, and the radius r. Important thing to note here is that if A is equal to r, in that case theta will be equal to what? If I write r over r, I'm going to get 1. So 1 radian. So that is how we define radian, 1 radian, right? So for a unit circle, r will be 1. In that case, the arc length A will be equal to angle theta, and both will be 1 in units, right? So as far as units are concerned, that is what the case will be. Now let's take another case. So this is case 1 if A is equal to r. Now if we consider full circle, let us say if A is equal to circumference C, which is 2 pi r. In that case, what happens? Well, in that case, theta will be equal to 2 pi r divided by r. Now r and r can cancel out, and what you're left with is 2 pi radians. So from here we learn that full circle is 2 pi radians. So if I have to go one full circle, then it really means 2 pi. Is that clear to you? Right. So this is the measurement in radians for a full circle. So now I hope you have understood everything on this particular screen. Important thing here is that if r is equal to 1, then theta is numerically equal to the arc length A, right? And the formula itself is ratio of arc length to radius is the measure of subtended angle theta, which we have written here. So ratio of arc length to radius is theta, correct? So I hope this part is absolutely clear. And for r equals to 1, theta is numerically equal to a. If a is 1, theta is 1. If a is 2, theta will be 2, right? So that is how they are related. Now with that in mind, let's take some examples and explore further. Here is our example 1 and 2. Question number 1 here is, find the measure of central angle theta that is subtended by an arc length A of 10 centimeters in a circle with radius r 4 centimeters. 4 choices are given to you. You can take your time, answer this question, and then look into my suggestions. I'll give you some more time reading the second question now. Question number 2 is, find the measure of central angle theta that is subtended by an arc length A of 3 centimeters in a unit circle, right? So in both the cases, we want to find the central angle theta. So theta is basically equal to the ratio of arc length to radius. You can apply this formula and get answer for both the questions, right? So let's do the first question. I hope you have already got the right answer. Theta is equal to arc length, which is given to us as equal to 10 centimeters, right? So it is 10 centimeters over the radius of 4 centimeters over 4 centimeters. You can clearly see that centimeter units cancel away. So radian basically is a ratio, right? So it does not have any unit. We say radian. So 2.5 is our answer. We may write this as 2.5 radians. We may write this as 2.5 with a superscript of c, right? Or we may just write this as 2.5. It is important to note, since radian is a ratio, we could also write a number 2.5, which will signify the angle in radian. Perfect. So here is a very important note for you, that radian is a default unit. For angles. Is that clear to you, right? So if no unit is given to us, radian has to be assumed, right? That is the unit, which is what we're talking about. So answer for the very first one is B, 2.5. Now let's do question number 2, where we are given arc length A as equal to 3. Unit circle means r equals to 1. And since we know that theta is A over r, it is simply, A over r, it is simply 3 over 1, which is 3. Perfect. So that is how you get your answer, and the option C is the right option. Let's take question number 3 and 4 now. Question number 3. Find arc length of a circle with radius of 10 centimeter if central angle is 2 radians. That superscript which you are seeing there is for radian, right? Is that clear to you? Okay, so let's write down what is given to us. What is given to us is so let's write down what is given to us. We have to find arc length, that means A is what we need to find, of a circle with radius 10, r is equal to 10. Central angle theta is 2 radians, so 2. So A equals to r times theta, that's the formula. So you can apply the formula here, 10 times 2, the answer clearly is 20. And so option D is the right option. Question number 4. Find the radius of the circle. So radius is what we need to figure out. Where arc length is 6, A equals to 6. Subtended angle theta is equal to 2. So R is equal to arc length over the angle, which is 6 over 2, and we get our answer as 3, the option B. So first 4 questions are relatively simple. As you've seen, we have used our formula, and that is related with A, R, theta. Is that clear to you? So that is an easy way to remember. Let's move forward. Example number 5 and 6. Example 5. Determine the measure of central angle. That means theta is what we need to figure out. That is formed by an arc length of 2 pi. So A is given to us as 2 pi with radius of 6 centimeter. R is 6 centimeters. So theta is the ratio of arc length to radius. So it will be 2 pi over 6, which is 1/3 of a pi. And the answer matches with B, pi by 3. Question number 6. Find the circumference of a circle where the arc length, so we need to find circumference, which is 2 pi r, correct? So let's write down 2 pi r. Find the circumference of the circle where the arc length A is 20 centimeters, subtends an angle of 2 radians. So theta is given to us as 2 radians. So first step will be to find r, and then we can find the circumference. R, as you know, is the ratio of arc length to the angle theta. So it is 20 over 2, which is 10. And therefore, the circumference will be 2 pi times 10, or equal to 20 pi. So the answer matches with D, which is 20 pi. So I hope the steps are absolutely clear. So now we are getting into questions which will involve more than one step. Let's see what is example 7 and 8. So questions for you. Question number 7. Find major arc length of a circle with radius 3 centimeter and subtended angle of 2 pi by 3. So this is, we might need some explanation for this, right? So let me first sketch the diagram, and then we will try to understand what is required, right? So that should help you to understand what is major arc length, and then we will actually answer the question, right? So let us say that this is the circle for us. We are saying find the major arc length of a circle with radius 5 units. So let's say that's the radius 5. Subtended angle 2 pi by 3. So 2 pi by 3 will be something like this. You've seen how to sketch angles in the previous video. 2 pi by 3. Now which one is your major arc? So that 2 pi by 3 is the minor arc. The major arc we are interested in is this portion. You get the idea, right? Now I hope the concept is clear to you. You can pause the video, answer this question, and then look into my suggestions. Now one way we could do this is we could find the major arc angle itself. So let's do this calculation. So if 2 pi by 3 is your angle subtended, we know here 2 pi is the total angle, right? So pi by 3, we have taken away 2, we are left with 4 of them. So 4 pi by 3 is the angle, which is this angle. You get my idea. You could also do like this. You could do pi take away 2 pi by 3. That gives you, or rather 2 pi take away 2 pi by 3, since full angle of a circle is 2 pi. So that is 6 pi minus 2 pi over 3. Or you get the same answer, which is 4 pi by 3. Is that clear to you? So you could find this. Now once you know that, and you know the radius, you can find the arc length, A. So you can say A equals to r times theta. R is 5 for us, and theta is 4 pi by 3. So when you multiply, you get your answer, which is 20 pi by 3. So 20 pi by 3 is option C for you. So I hope the concept is clear, right? So go through this part once again. It is a tricky question, but very important question from test point of view. Now let's see question number 8. Find the arc length of a circle with radius 5 centimeter that's subtended, central angle of 60 degrees. Now we need to find the arc length A with radius 5 centimeters, but the angle is given to us in degrees. So important step here is to convert to radians. So we need to convert this to radians. That is the first step which you should be doing, and then you should be solving the question. Then only you can apply the formula A equals to r theta, right? So you could apply this formula A equals to r theta, provided theta is given to you in radians, right? So let's convert this. So theta is 60 degrees. To convert, we'll multiply by pi, and we are going to divide by 180 degrees. So that gives you pi by 3. So theta is pi by 3 for us. Substituting the values, we get A equals to 5 times pi by 3. So 5 pi by 3 is the answer, which matches with B. Is that correct? So if the angles are given to you in degrees, then make a note. Convert angles to radians. Perfect. And then only you can use the formula A equals to r theta. Otherwise, this is not valid. So we are almost at the end. Last two questions for you, question number 9 and 10. So I hope the concepts are absolutely clear. Slightly difficult questions are coming on our way now. Here, the question number 9 is, find distance moved by a particle on a unit circle if the angle subtended at the center is 300 degrees. So now, if you look at it, we are trying to figure out arc length, right? That is what we are trying to figure out. It says find distance moved by a particle on a unit circle. So when I say unit circle, it means what? Unit circle means that we are saying that the radius is equal to 1 unit. And the angle subtended is 300 degrees. Theta is 300 degrees. So first step is to convert this 300 degrees to radians, right? So you could do 300 degrees times pi over 180, right? That gives you the conversion. Cancel zeros. Dividing by 3 gives you 10, and that is 6, and then further 3 and 5. So we get 5 pi by 3. Correct? So that is your angle theta. Now we can find what arc length A is. So A is same as theta itself, right? So R is 1, so R times theta. It is same as theta, which is 5 pi by 3. So option B is the right option. So what you've learned here is that on a unit circle, arc length is same as angle in numbers, right? The units are of course different. Arc length will be in this case in centimeters or units of length, right? Okay, so I hope you got the concept. That is how we are going to do it. The last question, question number 10 here is, find least number of revolutions along a unit circle to subtend central angle of 100 radians, right? So the idea is that we do have a circle. Let me just make a rough sketch of circle. Let's say this is our circle. So we are going round and round. So if that is the center, you're kind of making circles like this, right? Going round and round. Each revolution is 2 pi radians, right? That is important to understand. So each revolution is 2 pi radians. We need to figure out how many revolutions do we make to get 100 radians, right? So number of revolutions for 100 radians will be what? That is the question. Is that clear to you, right? So one revolution is 2 pi. So to get 100 radians, we will actually divide 100 by 2 pi, which is, you can say 50 by pi. So you can use a calculator to divide this, or you can say approximately pi is equals to 3.14. So 1/3 of this could actually give you the answer, but it is always better to divide it using a calculator. So when I divide 50 by pi, I get a value which is 15.9. So the question here is, find the least number of revolutions along a unit circle to subtend the central angle of 100 radians. So that 15 will give you just short of 100 radians, right? And therefore, the correct answer is 16. Does make sense to you? So that is how we get our solution, right? You could have divided 50 by 3 to get approximate answer. You could have done that, right? So 3 times 1 is 3, and this is 20. So 3 times 6 is 18. So you do get approximately the same answer, right? In fact, the correct answer. So you, without calculator, if this question was being asked, you could divide by 3.14 and get the right answer. I hope that makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Watch the next video on linear and angular velocity, clubbed with many questions from test papers. After that, we'll have a chapter review test for you. Thank you and all the best.